power electronics and architecture. So today let's discuss about the power electronics and the architecture that is involved in electric vehicles. So let's get into the details. So the basic question here is, what is power electronics? So we all know that power electronics is a branch of electrical engineering which deals with power conversion from one form to another using inductors, capacitors, semiconductor devices, and so on. This power may be from milliwatts to megawatts. So there are four types of power electronic devices. So they are AC to AC devices, AC to DC devices, DC to AC devices, and DC to DC devices. So let's discuss about each of them in detail in the upcoming slides. So the next question we have is, why the power electronics are used in automotive applications? The use of power electronics in automotive applications is critical for controlling automotive electronics. Automotive electronics include modern electric power steering, HEV, that is hybrid electric vehicle, main inverter, central body control, braking system, seat control, and so on. Vehicle power electronics primarily process and control the flow of electrical energy in hybrid and plug-in electric vehicles. They also control the speed of motor and the torque that it produces. Finally, power electronics convert and distribute electrical power to other vehicle systems such as heating and ventilation, lighting, and infotainment. Power electronic components include inverters, DC-DC converters, and chargers, etc. The Vehicle Technologies Office, that is VTO, is supporting research and development to lower the cost and improve the performance of power electronics in electrical devices like electric drive vehicles. In such roads, EVs and power electronic systems are used to drive the electric machine and charge the battery. So the main question here is, how the power electronics used in EVs, that is electric vehicles, and HEVs, that is hybrid electric vehicles. So first of all, let's discuss about the power electronics involved in electric vehicles. So the figure shown here is represents a simple diagram of an electric system drive which consists of battery charger, high voltage battery, DC-DC converter, bidirectional converter, inverter, electric motor, etc. So here the inverter takes direct current, that is DC electricity, from the battery and converts it to alternating current, that is AC electricity, and sends it to the motor. The electric motor uses the AC current to create torque and to power the wheels for propulsion. So that is how the power electronics involved in electric vehicles. So let's see how the power electronics involved in hybrid electric vehicles. So hybrid electric vehicles. So the figure shown here represents the increasing complexity of plug-in hybrid electric vehicles. So the HEVs use two electrical machines, one as a generator connected to the engine and another as a motor to drive the vehicles. Each of these machines are connected to an inverter, and the two inverters run at a higher voltage than the battery. To achieve this high voltage, another power electronics device called a boost converter boosts the battery voltage before sending the DC electricity to the inverters. Key components of hybrid and electric vehicles include motors, inverters or converters, sensors, control systems, and other interface electronics. So until now we have discussed about the power electronics involved in electric vehicles and hybrid electric vehicles. So now let's discuss about the types of power converter circuits that are employed in electric and hybrid electric vehicles. So in electric and hybrid electric vehicles, the power electronic converters are considered as the key elements that interface their power sources to drive the EVs. In order to design highly efficient converters for EVs power system, advanced DC-DC and DC-AC converters are required to adapt the output voltage and current levels with high power quality. So there are three types of converters which are widely used in an electric vehicles. So they are AC-DC converters, DC-DC converters and DC-AC converters. So let's discuss about each of them in detail. So the first one is the AC-DC converters. So the figure shown here represents a simple diagram of AC-DC converter. So the AC to DC converters are most commonly used in plug-in hybrid electric vehicles, that is PHEVs, and plug-in electric vehicles, that is PEVs. These electric vehicles get their propulsion from the external electricity source, which is alternating current. The battery needs to be charged using current source. So for this purpose, AC to DC converters is employed in PHEVs and PEVs. So next we have is the DC to DC converter. So the figure shown here represents the DC to DC converters, which consists of fuel cells, supercapacitors, batteries, etc. So the DC to DC converters can be used to interface the elements in the electric powertrain by boosting or chopping the voltage levels. By introducing DC-DC converters, one can choose the voltage variation of the devices and the power of each device can be controlled. The power of the DC-DC converter depends on the characteristics of the vehicle such as top speed, acceleration time from 0 to 100 km per hour, weight, maximum torque and power profile. So finally we have the DC to AC converters, which are also called as the inverters. So the figure shown here represents the simple diagram of DC to AC converters, which consists of battery charger, high voltage batteries, DC-DC converter, bidirectional converters, inverter, electric motors, etc. So the DC-AC converter is required to convert the DC power to a suitable AC power for the electrical machine. The power output from the battery pack is converted using inverter, which is used in electric motor. So that's it about the power electronics and the architecture involved in electric vehicles as well as in hybrid electric vehicles. Thank you.